Well, thank you very much for the kind introduction. So, as I said, my name is Nick Tansley. I'm speaking on behalf of Vanguard Sustainable Transport Solutions, and specifically about the upcycling of heavy transportation systems to zero emissions. So Vanguard is a spin-out company from the University of Birmingham, specifically the Centre of Rail Research and Education in the UK. And the team behind Vanguard was the ones that developed the engineering solution, specifically the control system around HydroFlex-1, the train that you can see on the right-hand side of the screen here. This was a conversion of a retrofitted electric train to run on hybrid hydrogen and battery propulsion. So building on those many years of experience, our business model is asset light and IP-led. So we're going to be licensing those conversions for local implementation alongside the development of hydrogen refueling solutions. So what's the problem we're looking to solve? So everyone knows that rail is largely a green solution, and that's perfectly true. And certainly using the UK as an example, and recognizing UK is broadly representative of the Western European rail network, roughly 80% of passenger journeys are indeed taken on electric trains. But that's on the most dense of routes, because it costs between £1 and £2.5 million per single track kilometre to convert a network to electricity. So therefore, about 60% of the network is not electrified. Therefore, roughly a third of the fleet has to run on diesel, which in turn contributes about 2/3 of the network's greenhouse gas emissions, along with plenty of NOx and particulate matter. As a point of reference, the UK network emitted roughly 2.3 million tonnes of CO2 during the year to April 2021, and recognised that was clearly a down year in terms of traffic volumes given COVID. It's also worth noting that the UK, along with many other Western European nations, is indicating a desire to remove diesel trains from the network by 2040. So what's our solution? Our solution is to use existing assets and convert them to be able to run on hybrid hydrogen battery propulsion, and therefore accelerating that shift towards decarbonisation. From a government's perspective, it's pretty clear they avoid the expensive infrastructure investment, that £1 to £2.5 million per single track kilometre. We can accelerate those emissions reductions. So trains are incredibly long-lived assets with very, very long investment cycles. So the speed at which we can deploy is much quicker than you can buy new trains. We can retain those socially important links. As mentioned, many countries are looking to remove diesel trains from the network by about 2040. We need a solution. And we can improve the local air quality. So again, the university has done some studies recently which demonstrate not only that the quality of the air is poor in those stations where trains are idling, but also on board the carriages where the air is being sucked back in and the passengers are forced to breathe those noxious fumes. From an operator's and a lessor's perspective, we can extend those asset lives. So as trains get cascaded down the network, we're seeing trains which are only 10 to 15 years old coming off and being scrapped. We can extend those assets. Trains can operate upwards of 50 years. We reduce the total cost of ownership. Electric trains are considerably more reliable and require much less onerous maintenance regime relative to diesels. We can improve the end user experience. Again, electric trains are smoother, they're more comfortable, there's less vibration, and the lower capex requirements. I'm starting with effectively a scrap train and converting it to something is at a fraction of the price of a brand new train, whether it's diesel or hydrogen. So in short, conversions provide all the benefits of electrification at a fraction of the cost. And it works. So this is HydroFlex-2, the updated version of the train I showed you a few moments ago, which we demonstrated at COP26. So on the left-hand side, we can see Helen from Porterbrook. Porterbrook owns the train, showing Prince Charles around the hydro chamber, and on the right-hand side, Boris taking a keen interest. This is a simplified diagram of HydroFlex-1. As you'd expect, a combination of batteries, of fuel cells, of hydrogen tanks, and so on and so forth. And our bit is really the systems integration and primarily the control system that keeps all this stuff working smoothly and safely together. It takes into account all sorts of variables in real time to make sure the train operates in a safe and effective manner. So I've spoken to you about the control system. And the control system is the core of everything that we do and the engineering around that. And the solution for a passenger train is different depending on its duty cycle. And then again, it's different for locomotives. But the core of it is all this same control system we spent many years developing. But every hydrogen train needs hydrogen. So we're also looking to develop hydrogen refueling sites. And these are scalable. So we maximize the utilization, given we know how much hydrogen is going to be used by the train. So we get that offtake certainty. And then on top of that, we have the ability to expand as the local authority, for example, sees that there's a hydrogen refueling point in place, then they may want to consider buses, et cetera, et cetera. Overlaying all of this, we have our high-sense optimization engine, which really links all of these elements together to make sure everything works smoothly and efficiently. Take into account, for example, weather changes. We can send instructions down to the driver, to the control system, and to the hydro hub to make sure everything maintains at an optimal level. And this IP has been many, many years in the making. So our CTO wrote the first paper in 2005. And then we had various projects in 2012 and 2018 of different scale models, kind of building it up, proving out that core control system and that systems integration, all the way up to Hydroflex 1, which you can see on the bridge over the River Avon at Stratford. And again, this is the first hydrogen train to operate on the UK mainline and the world's first retrofitted hydrogen train. All the way up to Hydroflex 2 on the top right-hand side of the train, a bigger and better version. And our pipeline is pretty full. So beyond these, we're partway through building our first locomotive type 1, so types 1, 3, 5, basically small, medium, and large. We're working on the next generation passenger train, and then also all the software and other elements required for both the Hydro Hub and the high-sense optimization platform. And the opportunity is enormous. So recognizing that Western Europe is largely electrified as a network, there are still thousands of diesel trains in operation in Europe. But frankly, the main opportunity is overseas, where it just is economically unviable to be able to electrify the track, whether it's because of the sheer scale of the country, whether it's the US, for example, or Russia, or whether it's a stage of economic development, where frankly, that infrastructure cost is so onerous that it makes no sense for them to be able to deploy. Given our solution is a fraction of that cost, we believe it can make a real difference. We see there's in excess of 150,000 diesel trains in operation worldwide. Now, depending on the duty cycle and so on and so forth, each of those trains could be using 50 kilograms a day for a light-duty shunter, for example, or several thousand kilograms a day for a heavy-haul loco. That's an awful lot of refueling, and that's an awful lot of optimization that needs to take place. And in turn, there's a lot of scope for emissions reductions. These are extrapolated data, and I think they're actually an underestimate because, look, trains operate for 50 years plus. They're not going to be running on the latest emission standards, many of these. And bear in mind that our model is to license those conversions for local implementation. So we're really priming the pump for local redevelopment, transferring those skills to accelerate that decarbonization. I gave the example earlier in terms of buses, think of what we can do on a countrywide scale. We develop those refuelers to maintain the offtake supply, and then we provide those optimization services to make sure everything works effectively together. So to summarize, rail is mostly green, but it can be a lot greener, particularly outside of Western Europe. Importantly, the economics do work now when you're comparing the cost of either electrification relative to our conversions, or increasingly as hydrogen costs come down, the cost of operating them on a day-to-day basis, and then you layer in the maintenance, it works. We're reusing existing assets. We're not building out new stuff. We're making existing assets last a lot longer than would otherwise have been scrapped. And again, we're accelerating that adoption. We're resolving that chicken and egg. We're supplying both the demand and the supply in one fell swoop, which then accelerate those broader-based decarbonization hydrogen economy efforts. So we're looking for partners, we're looking for friends and family to take this forward and collaborate with us.
So thank you very much, Nick. It was very interesting. And warm regards to Birmingham.
Thank you very much.
Thank you.